In this lecture, we're going to talk about modems. I know, right? How exciting! And the word modem is really just made of modulator and demodulator, modem. And modems are what we use for our internet connections. Regardless if you have DSL or fiber or cable or satellite, you have a modem. And I'm going to assume that there are still dial-up modems out there because some people just live too far from the central to get any other connection. With a dial-up modem, we take the binary data, then we modulate that into analog sound, we send that sound over the network, and then the receiving modem demodulates the analog sound into binary data. What we much more commonly use today would be cable modems, ADSL modems, and, if you're lucky, fiber modems. ADSL is an abbreviation of Asymmetric Digital Subscriber Line, and they use regular phone cables to carry their signal, but they use much higher frequency than the normal cable's frequency rating. If you're using an ADSL or any DSL connection and you still use a landline for whatever reason, you would need a data filter to filter those higher frequencies to make sure they don't interfere with phone conversations. We've already talked about how copper has attenuation. The further away you live from the central, the worse signal you get. So if you're half a mile away or 800 meters, you might be able to get 20 or 40 megabits. Now, if you're 2 miles away or 3 kilometers, maybe you get 1 megabit. And if you're 4 miles away or 6 kilometers, you may not be able to get any connection at all. The further away you are from the central or the last repeater, the signal strength drops, and that is the attenuation. And all DSL connections are not necessarily ADSL. They can also be symmetric, where with an asymmetric connection you might get 20 megabits upload but only 1 megabit download. If you have a synchronous connection, well then the upload and the download would be the same. Next up, we have cable modems, and those are the ones that use the coax cables. They were originally designed to carry TV signals, and because of that, they were designed with higher frequencies already, but most of them today can either do an internet connection, a TV connection, or both. And they can do that without the filter like the DSL. There's no interference because the different traffic uses different frequencies. You could also be lucky and have a fiber modem. Here, the ISP run the fiber all the way up to your door, giving you wonderfully fast internet. So my parents live in the middle of nowhere in Denmark. I think the closest city with maybe 3,000 people in it is about 5 miles away or 8 kilometers. So about 5 years ago, they had DSL. It was slow. On a good day, they might have 256 kilobit. And then for some reason, the power company decided to run fiber all the way out there. So now my parents, in the middle of nowhere, have synchronous fiber with 1 gig in both directions. Now, if you're not as lucky as my parents, you live in the middle of nowhere, well then maybe a satellite modem might be an idea. Up till recently, satellite has been pretty expensive, bad speeds, and high latency. But it looks like with Starlink, this is changing. We're seeing both good speeds and low latency. And then finally, powerline modems. They are reasonably new. I haven't seen them in a lot of places, but I have seen them. Here, the data signal is sent over the power lines. You plug your modem in, and that gives you an internet connection. I haven't really seen a lot of ISPs using them or even going that direction, but who knows? When we talk about modems, we have DTEs and DCEs. The DTE, or Data Terminal Equipment, is what we normally call the client. That is your desktop or your server. The DCE, the Data Circuit Terminating Equipment, is what most often would be the modem. That is your connection link between your inside device, the DTE, and the DCE. The DCE does all the signal conversion, the clocking, and a lot of times this is where the ISP's network ends. And you then have a connection to the DCE, and that is your network. Honestly though, most of this is legacy when you think about your home network. You don't have 2 boxes, or at least I hope you don't. You have a modem that the ISP gave you or the one that you bought, but in some businesses you will still see DTEs and DCEs, and in some router configurations you do the same. The ISP come out to your organization, they bring your router, that is the DCE, you then connect that to your organization's router, that is the DTE, and they will then synchronize if they can agree on the protocols, the clock cycles, and all that is set by the DCE. If they agree on everything, well then the connection is established. And this is also where the demarc or point of demarcation comes in. The demarc between the ISP and your equipment is where their responsibility stops and yours start. And with that, we're done with modems. I will see you in the next lecture.